Hey guys, so we are going to go ahead and try something a bit different today. I know it's kind of been a mess with trying to get used to this online learning stuff. Instead of posting the PowerPoints and trying to mess with the audio and have you guys listen and read to it, what I decided to do was just go ahead and make videos that are going to be going over the lessons. So hopefully that'll kind of clear up any confusion that you have on any of the concepts. And then, of course, I will go ahead and still post those PowerPoints. So if you need to go back and review something, say for a discussion post or any of the concept reviews, you can do that. So today we are going to be going over lesson 3. I know things got kind of mixed up, and that is my bad. On Monday, I was supposed to just post the PowerPoint on lesson 1, and then I was going to post your concept review on Tuesday, but I ended up getting confused and posting both of those things Monday, and then I don't know, I just kind of got messed up from there. So the good thing about that is that we're kind of ahead. So if you were able to look at the overview of our unit, which I've got hanging up here, and I'll kind of bring forward so you guys can kind of see. We have been going over our first section, which is energy concepts. So we have gone over energy forms and power and units, which was in lesson 1, and then we went over conversions in lesson 2. So if any of that was confusing, what I'm going to do today is kind of do a review on what the main concepts that you were supposed to be grasping onto. Hopefully, if you had any confusion, that'll kind of be dispelled here. So you guys will see me in my natural habitat as you do every morning at 8 o'clock. I have my coffee cup here, but there's Mountain Dew in it because it's like 3 o'clock in the afternoon as I'm filming this. So I just wanted to keep it as normal as possible for you guys. So let's go ahead and get started on our review. So I've got the main concepts up here for both lessons 1 and 2. So for lesson 1, we went over forms of energy. And what we mainly went over here were the 4 types of energy that we were going to be looking at throughout this unit. Again, these are just some fundamental things that I want you guys to remember. You probably already know a little bit about them from your physical science classes. But again, doesn't hurt to review so we know what they mean when those terms come up later in our unit. So we learned about chemical energy, heat and light energy, electrical energy, and kinetic energy. And I'm not going to go into so much detail about those things right now because if you listen to the audio that I posted up on Classroom, I gave the definitions and kind of explained each of those there. So if you're still unclear, definitely go back and listen to those recordings, okay? Second thing we learned about in this lesson was how we measured energy. So energy is measured in many different ways. The ones that we went over were joules, calories, and BTUs, or British thermal units. Again, if you need to know any of the explanations for that stuff, that is on those recordings. And then we went over the definition of power, which is pretty much the amount of energy per time. It's kind of how they calculate things before they use these measurements here. Okay. And then in lesson 2, we went over how energy is converted. So here we learned that all energy stems from the sun. And when it stems from the sun, then we see those primary producers. They will photosynthesize the sun's energy and then start kind of the flow of that energy, if that makes sense. So from there, we learned that energy relocates, and kind of an example of that on the slideshow, it showed how, there was a banana tree, and it got its energy from the sun, and it used photosynthesis to produce that energy further. And then I think it showed like a monkey eating the banana off of the tree, and it was just really kind of a simple chart of how energy flows. So we saw energy relocate whenever that chemical energy in the banana that was eaten by the monkey was relocated as mechanical energy for the monkey to use, like in its muscles, jumping through the air, and then again that thermal energy that monkey gives off, it is released into the air around it. So again, if you need to go back and review that, that is still on Classroom. And then we also learned, and this is going to be our a very important point for what we learned today, and that is that there is no creation or destruction of energy. So kind of what that means is that energy cannot be gained and it cannot be lost whenever it relocates. Okay, so though it seems to kind of disappear in the path that it goes in, there's no energy added and there's no energy that is lost here. Okay, so like I said, this is just kind of a review of what we went over. Today we are going to be going over lesson 3, which is talking about the laws of thermodynamics and their impact on ecosystems. So that will actually, if you look here, it will wrap up our first section of this unit, which is part C, which is the laws of thermodynamics. Again, if you want to print this out, I'm pretty sure you're able to off of the presentation, but if not, just let me know and I can send this to you via Google Docs and you can print it out that way. Okay, so now that we've done our review, we'll go ahead and get started on today's lesson. Alright, so what we've got here is pretty much just kind of what you were going to learn in this lesson. So lesson 3 is going to be the third part of our lesson over energy concepts, and it's going to be over the laws of thermodynamics. So your essential question here that you should be able to answer at the end of this is, what are the implications of the first 2 laws of thermodynamics? And then your objectives are that you can explain the significance of the first 2 laws of thermodynamics on energy resources and consumption. Okay, so I've kind of zoomed in for you to see, but what I did was I went ahead and printed off each of the slides that are in your lesson for today. So I'll just kind of go off of those as I explain things. So, what are the implications of the first 2 laws of thermodynamics? Well, the first thing that they give you on your slide, which you'll be able to access if you get on there via Google Classroom, is pretty much a review of energy conversions, and I believe they give you examples and images of how energy flows. So if you want to review the energy conversion concepts from last lesson, which was lesson 2, you can do that by going to this link here. Okay, so let's go ahead and get started on the laws of thermodynamics. So there are 2 laws that we are going to go over. So we have actually already learned about the first law of thermodynamics, and that was in lesson 2, in which I just kind of went over in the review. So it states here that in a closed system, energy is neither created nor destroyed. So kind of like I explained, whenever energy flows through producers and consumers, it will relocate, but there will be no energy added or destroyed. So that is our first law of thermodynamics. So you already kind of knew that. Now it just has a name. So there is also a second and equally important law to follow with thermodynamics. And this says that in a closed system, for all energy exchanges, the total useful energy will always decrease. Now, what they are talking about with the total useful energy decreasing, they are talking about efficiency. Okay, and you've probably heard the term efficiency used quite a lot. So, for example, back in physical science, the efficiency of a machine was pretty much how well it operated. So, the less energy that you had to put in to use the machine, the more efficient it was. So that's what we're kind of talking about here, but we'll get into more detail as the lesson goes on. Okay, so in yesterday's lesson, it'd be Tuesday's lesson, so lesson 2. They kind of gave you that flow chart of energy that applied to the first law of thermodynamics, where energy cannot be created or destroyed. So here they've given us something kind of similar, where it talks about the second law of thermodynamics, and it talks about the total useful energy decreasing. Okay, so pretty much what this flow chart is representing, obviously all of our energy, it stems from the sun, okay? And then we know that that energy stemming from the sun is then used up by photosynthetic plants. They are the first step in utilizing that energy and kind of starting the flow of everything. So once those plants photosynthesize that energy, then we have herbivores, kind of like your rabbits, small mammals that eat those plants, and then they will carry on the chain of energy. So I want you to keep in mind, while this is all going on, the total useful energy is going to decrease as we move on, like throughout the flow chart. So from there, it can go one of 3 ways. So it can either go to detrivivores, which are pretty much animals that are feeding on decaying matter.
Are you familiar with Zoom?
Sorry, I had to kind of cut that out there because there was someone talking in the background. But anyways, your herbivores will then be consumed by your detrivivores, which are animals that feed on decaying matter. So examples of these would be like your earthworms, millipedes, and certain types of beetles. Okay, the second way that it can go is through secondary carnivores. So secondary carnivores are, and it's in the name, carnivores. They eat meat, and mainly these are kind of like your spiders and snakes, and we'll see the main difference between primary and secondary carnivores. So our third way, which is through primary carnivores, these are kind of like big cats, like your mountain lions and your owls. These guys will only eat herbivores, okay? As compared to these, which will pretty much eat anything, okay? That's why you only see them stemming from the herbivores, okay? Once all of this goes through, and you can see all of this connects, they all use respiration, okay? And this respiration is pretty much a metabolical reaction and process that takes place in order for the animal's cells to convert that energy, okay? So once it goes through here, the heat unavailable for further energy will transfer. Okay, so now we are going to look at the 2 main environmental implications that the second law of thermodynamics has. So the first one is represented here, and this probably looks very familiar to you guys. In the first semester, we learned about trophic levels, and we did actually learn about how energy decreases as it moves up our trophic levels. Well, this is just kind of getting into the details of that. So, states here that available energy, and hence biomass, which again, biomass is just the total mass of organisms in a given area of volume. It will decrease as one moves up the trophic levels, with few ecosystems supporting more than 4 trophic levels. So we'll see here, remember that our trophic levels, they increase as you go up the pyramid. So there's your first, second, third, and fourth. On the first level, it's showing that there's 1,000 joules of heat energy that are used within that first trophic level. In the second trophic level, it decreases like by 10 times down to 100 joules. Then when you get to your third trophic level, it will decrease by another 10 times down to 10 joules. And then once you get to the very top, it will only decrease to 1 joule. So again, these guys only have 10% of the original energy that was first provided to them by the primary producers. Okay, and lastly, we'll go over the second environmental implication of the second law of thermodynamics. So it states here that man's available energy, whether it be used for heat, work, transportation, or electricity, is tied to the efficiency of each energy conversion, with no conversion ever capable of achieving 100% transfer of useful energy. So again, what the goal of efficiency is to reduce the amount of energy required to do something. So that being said, the higher percentage an efficiency is, that means that there is less energy being put into whatever it is that you're trying to accomplish. So they listed here for you like several examples of the amounts of efficiency in certain objects or processes. So first one says burning fossil fuel to get usable heat. This is about 85% efficient, so it's really not too bad. Now, burning fossil fuel to get electricity, that decreases the efficiency by quite a bit, down to 33%. Moving on to solar voltaic cells, these only get about 10% efficiency, so that means that there is a lot of energy being put in, but not a lot of like output or reward for whatever it is that they're trying to accomplish. Then we have using or charging a battery. This is 90% efficiency, so pretty good here. Again, you cannot get to 100% efficiency, so I would say 90% is very good. And then an electric motor doing work is about 85%, so it's kind of like the first one, has pretty good energy. And then drops down a little bit when we talk about typical internal combustion engines. Those are around 20%. So hopefully this kind of gave you some good ideas of what efficiency is and then how efficiency relates to the second law of thermodynamics. So in a way, I'm kind of glad that things got a little messed up, because that way we were actually able to finish our first section of our unit. So that means that next week we will be moving on to energy consumption, and I'll have to see how long each of the lessons are this weekend, just to kind of see how much we'll be looking at next week. So we'll be looking at energy consumption, we'll be looking at its history, and the present global energy usage and future needs. Again, if it's too long, I'm going to only try to do one section per week. But if it ends up that these are pretty small sections, then we'll go ahead and combine them just to get through as much as we can. But as you see right here down with nuclear energy, obviously that's going to take a full week or even more. So we'll just kind of see. But I will always keep you guys updated. So with this, tomorrow, which will be Friday, you guys will have your concept review questions, which you've had throughout the week. So there's only going to be like 5 questions on there. Nothing too difficult. Make sure that you're keeping up on your discussion posts and stuff like that. I don't know if I put this in Google Slides and in Google Classroom and any of the announcements, but kind of try to get your stuff tied up and turned into me by Friday night, if it's possible. The latest I will take it is Sunday night, but then again, I really don't want you guys putting it off until Sunday night and forgetting. I'm kind of guilty of that myself when it comes to online classes, and it's no fun being stressed out when you've got stuff to turn in, not only for my class, but I'm sure for others as well. So just kind of keep up on that. Again, set aside, I would say, like 30 to 40 minutes each day if you can, just to listen to the videos and then answer the questions, and you guys should be good to go. All right, thank you.